So in this part, we're going to proceed here to create our surface for our surface around our function. So we've stored these tangent and normal unit vectors into functions. So the next thing we really want to do here is we want to start characterizing our curve. Or yeah, I mean, well, not our curve. That's not right. It's really our surface. So let's define our new function. So let's call it surface. So now in order to do this, we need to find a point that's a given radius. So we also are going to want to define that. So let's say it's 0.5. For a certain radius, so there'll be a point there. So now we're going to have to consider another independent variable, which will be the angle theta. So this function is going to need time, and it's also going to need some theta value. So we described time. How did we do that earlier? Time. So we did 36. So we should do half of that. So let's add that here. Theta equals JP wind space. Let's go 0, pi 2, and then we'll do 18. Is that what we want? Oh, I don't know if that's in. Let's see. Okay. Alright, so we have that now. So let's get further into our function. So we just found those unit vectors, so let's store those in variables. Right, so pretty simple. Normal of t. So this is going to, in these bigger, capital T, capital N, we're going to store what is returned when we input a given time for our tangent and normal functions that we stored here, right? So then another thing we're going to want to do is, because we're going to want a vector that is perpendicular to both the tangent and the normal unit vectors. So something we can do to get that is going to be a cross product, or like a binomial vector. So we can call it B. So that should be, I think it's just dot cross. And then how does it want that? Just like that. Okay, so we have that now. So as we have this now, we want this function to return a stack. We want it to return a stack. So we'll have, stack, that's how it wants it. So then it wants our arrays. We'll characterize that by n, b, and it's one axis. And then we want to take this and we want to do matrix multiplication. And so we'll make our other array with our trigonometric. With our trigonometric function. So this is where we'll use that defined radius for the space away from the unit space away from the curve. So then we'll just want to do sine of theta, and that's where we're going to use our theta that we've defined. So we have that, and then we'll want our JP sine of theta, right? So that should be good. Okay, no immediate mistakes. Okay. So let's take this. I just kind of want to move the plot and look at it down here. And then let's add another code. So what if I did surface of T0 and data position 0. Too many indices. Okay. Too many indices for not. Well, can I just do like 1 and about like that? Ooh. The same thing I got earlier. Gotta make sure I put the period for floating points. Okay. So looking at this, this is telling us where our point should be from the curve. So at negative 1.5 for x, negative 1.5 about there, or sorry, negative 0.15. Okay, so it's right about there. Negative 0.15, negative 0.32 for y. Negative 0.32. We're in the center of the circle. Oh. That's because we need to add on our curve, really. So it should be T R M Z plus. Okay. There we go. Okay. So that should be correct now. Yeah, because now we're in like 1, 2, and 1/3. So like 1, 2, and then 1/3 up. Yeah. So that looks correct. That should be good. So we'll get rid of that. So now our next step is going to be vectorizing and completing the entire surface of this curve. So I'm going to do that in the next part.